go ahead and get started. My name is Chris King. I'm with a company called Palo Alto Networks, as you can see here. So the purpose of this presentation is really to provide a view into what we see as some interesting attributes of the modern threat lifecycle. And I think more importantly, because I'm sensitive to a lot of security vendors who get up and say, the sky is falling, you should panic, let me tell you some stuff. So I don't want that to happen. At the end, I'm going to finish with something that's very prescriptive, very process-centric. I'm also going to talk about some technology changes throughout the presentation. My background, I've been with Palo Alto Networks for about 5 years. Previous to that, had a similar duration stint at Blue Coat. And prior to that was an industry analyst with a company called Metagroup that some of you may remember from years back. And then even prior to that, I used to build networks for a living, so I was in your shoes. So brief introduction to the company. Palo Alto Networks is a California company. We are based in the Bay Area. All of our engineering, support, etc. is done out of Santa Clara, not Palo Alto. We are a recently public company. We went public back in July, and so we get to share all kinds of numbers and stats that are on official file with you, and you can look at them to your heart's content. 2 points I want to make on this slide. One, that we came to market in 2007 with something that was unique called the NextGeneration Firewall. And briefly, what a NextGeneration Firewall does is it acknowledges that long ago, applications and other types of network traffic ceased to care anything about port or protocol. So the main mechanism by which we governed access to our networks was port. And if all application traffic ignored port, then our contention was that the firewall can't do a very good job. Because essentially if you allow port 80, port 443, port 53, and port 25, you've just allowed most of the internet with zero control over what's coming in over those ports. More on that in a minute. So, as I said before, I'm not going to stand up here and say that the sky is falling. There's been a lot of documented discussion, both today already and in industry previously, about the nature of the change in the attack landscape. And I think we can boil it down to 3 things. One is the players changed. So yes, we have much more sophisticated attackers than we've ever had before. 2, the strategy has changed. People are going after higher stakes stuff. You know, think about it in a physical security context. If you're going to knock over a hot dog cart, you can probably do that opportunistically. If you're going to try to knock over a bank, you're probably going to have to do a little bit more planning. And so that gets to this 3rd point, which is, or actually I'm still on the 2nd point, we're moving away from opportunistic attacks. We're moving towards more strategic attacks, things that go after bigger stakes items, intellectual property, public functions, etc. You guys know about this as much as I do. The 3rd point here is when you do that prep, going back to my analogy of knocking over the bank as opposed to knocking over the hot dog cart, you're gonna take more time. It's worth your time to do sophisticated surveillance of the target. It's worth your time to figure out the weak spots. It's worth your time to dedicate a specific type of attack where I'm going to use multiple tools. I'm going to use a drill, I'm going to use dynamite, I'm going to use electronic signals, interruptions, and things like that to get myself into that map. And so, you know, again, I go back to the public service announcement we have up here. This is not my objective to say that the sky is falling. I'm not up here to try to generate a lot of FUD, but I am providing this context to start to talk about some of the challenges that you guys face in your organizations and some of the ways that you might address it. So, brief tour. Again, a lot of you will have seen some of this before. There is a kind of these multi-step, multifaceted, patient exercises to get into organizations with the idea that there is a long-term benefit to the attacker in being in there. Again, not knocking over the hot dog cart, but taking your time and getting into an organization, footprinting it, figuring out what's going on and how to exploit that organization. So you have these multi-phase kinds of approaches to breaking into organizations. You know, you start off with a phish, maybe you move to an application-specific exploit, maybe you use some targeted malware, where it's not a broad-based attack that we've seen in the previous decade, but something that's very, very targeted to just an organization or a group of organizations, and we're off to the races. The important thing is, a lot of these attacks are basically network applications. So they're communicating back and forth with the attacker. It's not a simple set it and forget it kind of attack. It's a matter of going in, collecting intelligence, and communicating, waiting for further instructions. More on that in a minute. So, I forgot there was a build here, sorry. But these kinds of things where you have these multi-phase attacks, once they're inside, then they've got that ability to do command and control, communication, etc. Now there are a couple of problems that we have, or a couple of challenges in a traditional network. The first issue is our defenses are siloed. So we have technologies in place. Everybody here has a firewall. I'm not even going to ask anybody to raise their hand. Who here doesn't have IPS? Okay, so we got one. Who here doesn't have AV at some level? All right, so most of you have some basic technologies in place. Many of you will have anti-spyware. Many of you will have URL filtering. Most of these operate in silos. And I think the industry, one approach that the industry had to address this was, okay, let's build this thing called SIM. And we'll harvest information from all these kinds of things, and we'll try to forge some sort of informational context around it. What you don't have is IPS or AV or a firewall doing something in context, sort of knowing what the other things know. The only place you know everything is at this pane of glass. Second piece, the threat developers are smart. They know that applications know how to get past your defenses. If your firewall is allowing access to your network based on a port number, and applications circa 2000, 2001, starting with the AV vendors, moving to the IM vendors, and now moving to everything else out there, and I'll give you some statistics on this in a second. Basically, the application developers know how to get around those defenses. They know how to build firewall-friendly applications. And the threat developers know that, so they piggyback. You look at any of the industry bodies, whether it's a SANS or any of the vendors that focus on vulnerabilities like a Qualys or somebody like that, they're going to tell you that 80% plus of the threats that you need to worry about today that are going to target, public sector, private sector networks, they're application level. They're either exploiting an application or they're using applications as a conduit. Third piece, targeted or custom malware is becoming a lot more common. And the trick here is, and a lot of people will feel this anecdotally. What they'll say is, my AV vendors aren't being responsive enough. It's taking 6 days, 7 days, 2 weeks for me to get a signature to something that's running around today. Now, I'm not going to let these guys off the hook, but think about something. What they've done is to build a very robust infrastructure to collect threats from all over the globe. They've got honeypots in universities all over the globe. And when a threat developer developed broad-based attacks and threw them out all over the place, I remember sitting in, back in the 90s, sitting at my desk early one morning and seeing something coming from Japan saying, it's going to be an interesting day. And that was the day that I think it was either Code Red or NIMDA hit. And you just saw it ripple around the world. And it made its way into all the honeypots. Now let's say I'm just going to use a targeted threat against Caltrans or FRB. It's never going to make it into the honeypot. The AV vendor's never going to get a sample. That's the problem. It's not an inherent flaw in signature-based technologies or anything like that. The problem is the AV vendors or anybody else in the industry they're not going to get that sample because it's only targeted against one particular organization or two or three. So these are some of the challenges we have with our traditional mechanisms of firewalls and IPSs and AV. Now, some statistics on this. We have a technology called Wildfire. I'll tell you more about that in a minute. One of the things that we get to do is look at some of this targeted malware. So we have hundreds of organizations, again, both public and private sector, that are sending us unknown executables. Executables that no one's ever seen before. And they have their firewalls set up so that when they say, hey, this is a high-risk application, maybe it's Twitter, maybe it's Facebook, maybe it's SharePoint that's hosted by a partner, send the executables up when I've never seen them before. And these executables are exploded in a sandbox. I'll talk to you more about this in a second. We see about 15,000 new pieces of malware a month right now. Some of the interesting bits around that, a huge percentage of them, 66%, at time of discovery, are not recognized by any of the major AV vendors. Again, not letting them off the hook, but the fact is, it's not their fault. These things are not yet making their way into the Honeynets. Next piece, many of these things are generating evasive network traffic. So they're going out over a peer-to-peer network, or they're going out over some proprietary protocol that uses port 53 or encrypts via SSL. And then the third piece of this is going back to that idea of a multi-phase attack. The next step was, once they establish communication, let me find out what else I can do. How can I footprint the network, et cetera, et cetera. So I've got some interesting evidence here based on actual data, again, across about 15,000 new malware samples that we collected that sort of supports those points of not making it into the Honeynets, doing lots of evasive stuff, and conducting secondary and tertiary steps when it comes to attacking the organization. So a couple of recommendations here. When you look at threat prevention, and notice I didn't use the term AV or IPS or anti-spyware, threat prevention. Some things you got to think about your technology infrastructure doing. Sorry. One of them is having visibility into all ports. Having visibility into all traffic. Being able to understand what that traffic is, regardless of whether that traffic is encrypted, whether it's evasive, whether it's port hopping, whether it's on port 80, port 53, port 25, port 443, etc. Second piece, of the known threats, have a mechanism to stop them. I don't care whether it's malware, spyware, an exploit, something else. Have that ability to know a known threat, and arguably a known source, regardless of whether we're talking about an exploit, a virus, something else. Be able to do it across those silos. And third, have an approach to address the unknown threat. So you're going to ask the question, so if I don't know what it is, how do I have an approach to do that? More on that in a minute. But these are kind of the three parts that we think about, again, from a technology perspective. I'll come at this from more of a process-based perspective in just a minute. So let's start with those first two. Know what your traffic is and be able to identify and stop the known threats within that traffic. So we do something every 6 months called the Application Usage and Risk Report. This last time around, we looked at actual network traffic. This is not a survey. This was actual network traffic on over 2,000 public and private sector organizations worldwide. So this is unique. Nobody else has this information. We have this information because of the nature of our product. I can share more with you on how we collect it after this presentation if you're interested. But what we have is very good statistics on what applications are running on networks. You see a lot of surveys. I think it's probably more on the private sector, but you see a lot of surveys where they say 54% of private sector CISOs say they block Facebook. I can tell you that 96% of all enterprise networks have Facebook on them. So there's a little bit of delusion there in a lot of cases for the private sector. More to the point here, a large percentage of the application traffic that we see on enterprise networks is capable of evading traditional controls. So they operate on non-standard ports, they port hop. You look at something like Skype, which is an amazing piece of code. Even today, I'm still just stunned by the genius of those guys. I mean, Skype will try some 26,000 ports in a very short amount of time to try to escape the network. It's a really impressive piece of code, just looking at it from a pure computer science perspective. From a network security perspective, it's an absolute nightmare. But from a computer science perspective, you gotta admire it. Another thing that we found that I think we found on average, the average enterprise class organization, again, both public and private sector, has some, I want to say, 500 or 600 applications on it. Of those, roughly half start tunneling things. So you look at something like, well, SSH, that's an IT tool, right? Well, yeah, but it's pretty well established. Anybody in the IT space, or not, even outside the IT space, is very capable of setting up SSH reverse tunnels. Again, on non-standard ports potentially. So there's lots of applications that I would argue are kind of high risk, high reward. SSH is not a bad application. It's, in fact, an invaluable tool for managing your IT infrastructure. It's also a complete disaster from a security perspective because it can tunnel other apps, it can be operated on non-standard ports quite easily, et cetera, et cetera, et cetera. The point is, there are a whole bunch of these applications that fit into this class of specifically being able to subvert the information security controls that you have in place. And then lastly, there are some that are specifically crafted to do just this. Are you guys familiar with an application called UltraSurf? Many of your colleagues in the K through 12 space, this is the bane of their existence. If you say UltraSurf to a high school IT administrator, they're going to shake their heads and go, I can't keep up with these kids. Because in a lot of cases, UltraSurf, I mean, these are folks who rewrite their entire application in order to escape detection every 3 or 4 months. Tor is another one. Tor is a legitimate business application. If you are a spy, if you're in the intelligence community, the Onion router is a very useful tool. If you're trying to evade detection in an oppressive regime, Tor is a very useful tool. It is also very useful for circumventing network security controls, which is, there are those who believe that working in a lot of organizations, they're operating in an oppressive regime. Some of you in the security space for a while may remember a few years ago, the Wall Street Journal actually published an article on the top 10 ways to evade your network security controls. So this is not stuff that's for geeks only. This is stuff that's in the mainstream media. You can use proxies.org, you can use anonymizers like Tor, UltraSurf, Hamachi, you can set up SSL proxies on your machines at home. There's a million ways to do this. And again, these aren't users who necessarily want to bring threats into the network. What these are users who want to circumvent your controls so they can do the things that they want to do. In rare cases, they might actually be doing their job. In all cases, they're subverting the controls that you put in place to stop threats from coming into the network. So just a quick nickel tour here of kind of what we see in terms of tunneling. So what the firewall sees in this case is port 443. The assumption is that that's HTTP over SSL. In a lot of cases, both of those assumptions are wrong. But let's just say it's right. So the firewall sees 443. What we're actually seeing is SSL traffic. You peel that away. Then you say, okay, that's HTTP. You peel that away. That's actually Google Talk. You peel that away, and there's a file transfer within there that may or may not contain malware. And this is what I mean by tunneling. You've got tunnels within tunnels within tunnels in a lot of cases. And you might have a specific network security control that looks at one element of that, but the rest of it it's ignorant of. So again, any of these controls that focus on kind of, well, port is a good proxy for any of this, they're going to be sorely mistaken. So the thing that a next generation firewall does is it throws out all those assumptions. So basically, the idea behind a next-generation firewall is before I make an access decision, I figure out what that traffic is. I figure out what that application is. I don't care what port it's on. I don't care how it's behaving. I don't care what encryption it's using. I need to figure out what that app is before I say, yes, it's allowed onto my network. The way I like to illustrate this is, if you're doing things by port, it's the equivalent of getting a knock at the door, going to the front door, putting on a blindfold, opening a door, leading the person into your living room, then taking off the blindfold and figuring out, should I hit them with a bat or offer them a drink? What I'm talking about doing is actually using the peephole and figuring out who that person is and what they want before you open the door. And that's the difference between a next-generation firewall and everything else that's out there. So what the next-generation firewall does across those issues that I talked about, across non-standard ports, tunnelers, circumventors, is it figures out what that application is, regardless of what port, what it's doing across all of that. It does progressive decoding. So it starts peeling away all those tunnels I was talking about until it figures out what the core of that application is. And then finally, it's capable of using a bunch of different techniques. You look at Skype. There is no decrypting Skype. It uses proprietary encryption. So you have to use a different technique. You have to use heuristics. There are other applications you can use signatures for. You end up having to do decodes across multiple application protocols potentially. The point is, you have to use all these different techniques, again, before you allow the traffic onto your network in order to address these challenges that I highlighted. So, what does that get you? Classic defense theory. Control the avenues of attack, and your job of defense is a lot easier. And what you see here is the idea that there's this big bad world of applications out there. Many of these applications are actually good. I know a lot of agencies are using social media extensively. Social media is how you're going to interact with constituents. Social media is how in the private sector you get new customers. Social media is the preferred method of interaction for a lot of younger folks, even older folks, who say this is a simple, high leverage way I can interact with people. It is also the favorite method to transmit attacks. You look at Facebook as a great example of this. Anytime you have 1 billion people in one place, that is a target-rich environment for attackers. Period. End of story. So all of the attacks are going that way. So what you have is a mix of these applications. It used to be that you had a business app and a threat. One was good, one was bad. Now what you have is a whole bunch of applications that are both high risk and high reward. They're going to be how you reach constituents. They're also going to be how that attack gets into your organization. So the first point is, when you look at this diagram, you say, let me cull down the numbers of applications that I allow onto my network. Yes, I'm going to use Twitter. Yes, I'm going to use Facebook. I'm going to use SharePoint. I'm going to use SAP. I might even use Skype. I might use YouTube. I might use Vimeo. But the other 100 streaming video applications, I don't need to have on my network. I might have approved social media kinds of outreach, but I'm not going to use Tumblr. I don't have a need for Pinterest. And the point is that if you start to limit those things and say, I'm going to allow these 20, these 40 applications on my network, all else deny, I don't care about the other 100,000, 2,000 applications that are out there. I'm going to focus on these for these users. Then my job of cleaning those applications from known threats is a lot easier. I don't have to scan everything under the sun. I only scan the applications that I want on my network. All else deny. That is kind of a basic firewall concept. The whole idea of a positive security model. Allow A, B, C, D, E, and F. All else deny. Don't care what they are. Once I do that, then I have this ability to inspect for threats on the traffic that I've allowed. So that is one of the primary benefits of doing things with the next generation firewall. Now, so I promised, what about the unknowns? So how do you deal with the stuff that's unknown? Let's talk about that for a second. So as I mentioned before, a lot of the vendors in this space who provide protection against exploits, malware, spyware, etc., they depend on a collection mechanism. And that collection mechanism is usually an array of Honeynets, which are made up of honeypots. Everyone uses the same kinds of feeds. There are dedicated companies out there who do nothing but operate these Honeynets and feed these samples to all the security vendors, us included. The problem is, a lot of the targeted and custom malware, a lot of the stuff that's polymorphic on the server, never makes it into the Honeynet. Never gets in there, as I said before. And so what happens is, you get this variable time of protection. And I'll give you a specific stat in just a minute. But you get these things where it takes 3 days, 7 days, 14 days for an AV vendor to get a hold of a sample and develop protection. And again, this is, I think it's been well documented about the complaints, but I don't think too many people have explored the why. And I know I sound like I'm apologizing for a lot of the AV vendors up here, but I mean, this is a structural issue that's difficult to address with their existing collection methods. So what Wildfire does, and Wildfire is a sandbox-based technology that we've developed to get a hold of some of these unknown, never-before-seen threats. So our next generation firewall will sit in a customer's network, and the customer will say, I want to allow SharePoint, I want to allow Facebook, whatever. But if you see unknown executable content coming over that, ship it up to this thing called Wildfire. Now remember, a firewall is something that is inline. It has to be low latency. It's part of the network. It's a network security device. So you can't introduce a lot of latency into the equation. So what we've done is we've created this thing in the cloud that is, you guys have probably heard the term sandbox before. I know that a few California agencies from my days as an analyst did a lot of experimenting with sandboxes, particularly some that sat in line. And there were a lot of complaints about sandboxes that would introduce seconds of latency into network traffic. And usually those sandboxes were torn right out because of that. So what happens is this isn't executed in line in the network. This is executed in the cloud. And what we're able to do is let that thing, let that unknown executable flourish. It can do whatever it wants to do. And doing it in the cloud, we get that benefit of saying, it's not on your network, so we can let it do whatever it wants. If we were exploding this on your network, we'd have to be a little bit more careful. We couldn't let it walk around and footprint everything. What we can do is let it do whatever it wants, because all these guys are aware that there are sandboxes out there. All the threat developers are looking for, hey, is this a sandbox? If so, I'll shut myself down and I won't give away my secrets. We let it develop completely. And then we return a result to you that says, hey, that thing you dragged in from Joe user, and we'll give you the specific username because we have access to that, across SharePoint at 12:38 p.m. this afternoon, it exhibited the following behaviors. We think it's malware. It changed the registry. It wrote these files. It changed this thing or that thing. You might want to go address it. And by the way, we'll spin a signature so everybody else, again, public and private sector, who has our firewalls are able to be protected from the thing that you found. Yes, the one user you have is infected and will need a re-image, but everybody else in your organization will have protection after that fact. So that's kind of what Wildfire does. Here's an example. This one's a little bit dated. We came out with a more recent example, Aspertium. Some of you may have heard of that. I have to replace this slide with the Aspertium slide, but I like this one because it exhibits everything that I've talked about. So Jericho was a banking Trojan that we uncovered back in April. And it came in via applications, it generated evasive traffic, it footprinted the organization, it downloaded additional stuff. The other thing is that it wasn't immediately detected. So you look at day 6. On day 6, 40% of the AV vendors could detect Jericho. And Jericho was interesting because it polymorphed a little bit. It actually randomized the components that it called, so it looked like a new piece of malware every time, but it actually wasn't. But it fooled all the AV folks. So in that randomization, until they figured out how this worked, in that randomization, they were able to stay under the radar for a long time. We figured it out because we exploded it in our environment and saw what it did. But the point that I'm making is all of the things that I'm talking about, coming in over applications, generating evasive traffic, doing additional hacking, etc., it did all that. And it wasn't detected on day 6 by 60% of the AV folks out there. So the other thing that we've uncovered, and this is in sitting and talking with customers. I had a customer, it was actually now a couple of years ago, call me up and say, or actually didn't call me up, called our threat team up and said, love the product, I know what most of my traffic is. And the thing that that customer said is, because I know what 85 to 90% of my traffic is, I get to spend time on the remaining 10 to 15% of stuff that I don't know. If 85% of your traffic is unknown, you can't do anything. If 15% of your traffic is unknown, you get to spend time digging into that traffic and figuring out what it is. And what this customer said was, hey, I'm seeing these strange 7-byte encrypted UDP packets. Can you have a look? So our threat team said, sure. Decoded it, figured it out. Turns out that was the command and control channel for a botnet. It was one that has since been decapitated called Mariposa. The point that was raised then and has been raised in multiple discussions with customers that I've had since is that if you know what the majority of your traffic is, then you can spend time on the unknown bits. So another customer in the government of Nova Scotia, I know that sounds kind of obscure, California's this big and Nova Scotia's about that big, but what he said was, I get to do the things I always wanted to do, but couldn't because I was too busy putting out fires. So now I'm in a situation where because I know what most of my traffic is, I can dig into that remaining 5% and start doing investigations. Now whether that's a new application that the application development teams didn't tell me about, and I have to sort of develop an app ID, and that's a technology that we use to discover applications. I have to write an app ID for that, or whether it's something that's never been seen before. Now we also have some other capabilities around looking at suspicious behavior within the network. So you can say, we have a behavioral report that says, look, I can't tell you this is malicious, but there's a particular desktop or application here that's doing a lot of suspicious things. It's making a lot of DNS calls. It's going to dotted quads in Bolivia. It's doing a lot of stuff over port 53. Those are all kind of yellow flags. Nothing substantive, nothing that we can say that's malicious behavior, but again, because we've pushed away the majority of things, let me say it another way, because you already know what the majority of things on your network are, you can spend time on things like this, where before the noise floor was too high. So I promised I'd sort of tie this all together, and I will, as it turns out, I will have some time for questions and answers afterwards. So let me do that. From an approach, from a strategy in terms of taming the modern attack, or breaking that life cycle, as I term the application here. There's an approach that we're advocating, and again, this comes from lots of discussions with customers. And basically, as you move from left to right across this slide, what you're doing is dramatically reducing the risk. And the idea would be, if you start looking at applications and you start controlling which applications you want on your network, again, not by port, not by whack-a-mole with bad apps, but by saying, I have a situation where I can as an agency, say, these are the 100 or 200 or 500 applications that are important to me. They might be groups of apps. They might be certain applications for certain groups of users. You might say anybody in public relations might be able to use these sets of applications. But I don't want normal clerks being able to tweet in the middle of the day, or something to that effect, a policy like that. So the idea is that you control which applications you want on your network positively. Allow these 10, 20, 100. Dramatic reduction in risk right there. Second piece of this, there are known sources that are bad. Okay, we know that if you look around the world, there are certain countries that are hotspots. Certain countries in Eastern Europe, certain countries in Latin America, certain countries in APAC, various places that are, if you don't do business with them, you probably don't need to have traffic going to and from. You know, we have had several customers that say, wait a second, I don't do business in New Guinea. I don't do business in Somalia. Why do I have network traffic going there? Good question. So doing those kinds of controls will greatly reduce the risk associated with certain types of traffic. So first step, applications. Second step, sources. Third step, known bad threats. So again, going across silos. Not looking at it as a pure virus or a pure malware or a pure exploit. It's threat prevention. And a lot of organizations in the private sector are starting to move this way. Some major Wall Street banks are moving this way. Some major manufacturers are moving this way. They're actually starting to combine their CERT teams in a lot of cases. Actually, that's redundant. They're computer emergency response teams. In some cases where we've seen 3 CERT teams go down to 1 or 2. Again, in sort of Fortune 50 companies. Because of this need to have this shared intelligence across what had been previously silos. Remember, I identified that early on in the presentation as those silos that we have are part of the problem. We got to break those down. And then this last piece here is we're getting down to a fairly small point. We're getting down to a small percentage of traffic down here. And we've had lots of jokes about sort of Rumsfeldian logic here when we talk about known knowns and known unknowns and unknown unknowns. But the thing is that when you start talking about unknown threats, there are things that you can do in terms of investigating unknown traffic. And then there are things that you can do for kind of exploding those unknown executables. And I hope I've kind of shared a little bit about both of those items. One is when you start talking about investigating unknown traffic, digging in, figuring out what that is. Whether that's a new application that the production acceptance process didn't go so well and the network team didn't find out about it, or whether that's actually some sort of command and control channel. And the second piece of that is, for the unknown executables that are coming in, blow them up. You know, send them to a sandbox and get them exploded, figure out what they do, and so on and so forth. Probably want to do that in context. If it's something that's coming from a trusted source in the data center, you might not need to explode it. If it's coming from the outside, it might make sense. So hopefully this gives you kind of an idea, a framework, a way to think about kind of breaking that life cycle that I talked about before. So I have a few minutes here, about 10 minutes for questions, if you guys have any, please.
If you implement a next generation firewall, do you still recommend an IPS?
Good question. So the question was, if one implements a next generation firewall, do we still recommend an IPS? We recommend that you preserve defense in depth. So there's a couple ways to think about defense in depth. The traditional way of thinking about defense in depth is, I need to have lots of vendors in my network. An alternative way to think about defense in depth is, I need to do multiple things, multiple types of controls, again, going back to this. So if the firewall addresses the application issue, and you have a subsequent content scanning step for allowed applications, that addresses that defense in depth. If you have the same technology, the same scanning engine scanning for both applications and threats, that does not address the defense in depth approach. without getting too vendor specific and too pitchy, what we have is a firewall that uses a technology called App ID that identifies and controls those applications. We have a subsequent technology called Content ID that for allowed applications then scans those things. So what I would argue is that we preserve defense in depth from a technological perspective, and yet you benefit from some of that shared context. So when you create policies on our firewall, you can say, if it's SharePoint hosted in my data center, I don't need to scan it for threats. If it's SharePoint hosted by a partner or in another agency's data center, I do need to scan it for threats. So you have that shared context across that. So I hope I'm answering your question. Our threat prevention capability has been tested by NSS and is recommended and scores very highly and all that good stuff. But I think it's important to kind of, I think where your question's coming from is defense in depth, and I think that you address it with technology and not necessarily across multiple vendors, because when you do the multiple vendor step, you end up with those same silos.
Right. I was kind of leading to my second question is, the old school thought was having multiple vendors, so if one fails to catch it, the other layer will. And if you do that, then you're in silos to some degree.
That's right. No, and I mean, you listen to Neil McDonald at Gartner, who's pretty good at figuring things out and connecting the dots. He's really big on context right now, and where he's focused is saying, okay, if you don't have an understanding of which app, which user, what kind of content, when you're doing network security, then you're going to miss a lot of stuff. You know, those traditional silos, there are huge gaps between them. And his argument is, in a lot of cases, context is more valuable than any one silo in itself. Not my words, but you know, it might, if you guys are into it, I would check out some of his writing on context. Other questions, please.
If you have a portable environment or a portable OS with a malicious toolkit, how can this tool identify that, whether it's a USB, a UPS that's been hard-coded with malicious code? How can this tool allow me to identify that in our network?
So, great question. In an environment where you have multiple types of devices, you know, USB keys and things like that, how can we help? I mean, honestly, we're completely focused on network security. So where we're going to catch stuff is where it hits the network. So if it's a USB that's moving around the physical environment, nothing we can do. The minute you plug it into a laptop that's connected to the network, we're going to catch it. Second question, or maybe the first part of your question is, you know, you're using a mobile device and it's infected, right? It's been jailbroken, it's got malware on it, whatever. If it's on the carrier network, you know, there are ways we can loop it back in with VPN tunnels and things like that. We're doing that for some of our customers. Most often, you're going to nail it when they connect to the Wi-Fi. And again, in a world where, and this gets a little bit of feel to this conversation, but in a world where the end user owns the device and the application's hosted somewhere else, the only thing that you control is the network. And that's the thing that we're trying to secure. So the minute they climb onto the network, we're going to catch them. The minute the application is used on the network, we're going to catch it. But that's actually the common thing that you might actually have some control over in a BYOD cloud-based app kind of environment. But again, that got a little feel. Question?
Just want to introduce myself. My name's Matt. I work with Palo Alto Networks, and for those of you that are interested, if you stop by our table downstairs in the vendor forum, we've got some free booklets on next-generation firewalls and modern malware that will go into some of Chris's topics in detail and in depth. And for those that really want an in-depth demo of this in action, we're going to have the ability to do some of that at the table, but we've also got a meeting room from 2 o'clock to 3 o'clock today where we're going to go in and do a full-blown demo of the product in action. So just wanted to give you a heads up.
So the question was wired versus wireless, which one's more secure? And the perception in government is that wired is inherently more secure. I could argue that either way, honestly. It's not really our business to debate it. What I can tell you is that in both public sector and private sector, we do a lot of network segmentation across both wired and wireless. So for example, in a lot of healthcare networks, guest wireless is big. That is a major project for both public sector and private sector healthcare organizations. Almost all of them want to provide patients, people in the waiting room, etc., with a relatively contained, safe web browsing environment, for lack of a better term. Doing that in a way that is controlled and available, as opposed to the this is a true story. And I forget what function he was in. I think it was an administrative function. Set up a file sharing server in a closet using the guest wireless in a hospital, and the customer, our customer, was able to find him in 10 minutes. And the question was, how'd you find me so fast? But the point is that wireless. The reality is that you're going to have wireless networks. So, are you going to see servers connecting to networks via wireless in the data center? Probably not. Are you going to see, in the case of, for example, a large insurance company based outside of Chicago, they're going to move everybody to wireless, and they're going to basically treat their user LAN as public internet. So, there's the idea that wireless is inherently less safe is essentially acknowledged and built into their infrastructure. I hope I'm answering your question, but what I'm kind of getting to is it's a reality, and there are additional safeguards that you can take. But I think that if you look at what John Kindervag at Forrester is advocating with his zero trust network architecture, what he's doing is saying the idea that there is trusted network anywhere is kind of passé. And you need to do segmentation across all of your network, whether that's wired or wireless. So I hope that answers your question. I mean, if I can paraphrase for the benefit of the camera, from a technology perspective, is wireless inherently less or more secure? And I guess the thing I would argue is wireless, because of its nature, is inherently less secure because you don't have that physical isolation, but because of its implementation, which has a lot more controls around it, you could argue it might be more secure. Whether we're talking about 802.1x or those kinds of things that might be implemented on wireless and might not be implemented on wired. I mean, again, I think those two are very hard to separate. You don't hear as many stories about war driving anymore because people have really started to lock down, I mean, except in coffee shops, I'm talking about in major enterprises and agencies. You don't hear as many stories about that anymore. And I think there is an inherent openness to wireless, but the number of controls that people have placed on it in their implementations probably offsets that a fair amount. I can tell you that we do network segmentation projects using our firewall across both wired and wireless LANs. So I think one more, and then I'll call it time.
All right, Chris, I have a two-part question. So your product, the NextGeneration Firewall, does it affect WAN utilization since it's sending the traffic over to Wildfire?
Interesting question. We have not seen any substantial impact because what it's typically doing is only sending the unknown executables across the applications that you've specified that for. So you might say, these are the 4 high-risk applications that I want to ship unknown executables across for. So in other government networks, for example, if it's coming from inside, they don't want to send it. If it's coming from the intranet, the internet, they want to send it. So it's the internet apps that are likely to transfer files that have unknown executables. So I've not seen any measurable impact on customer networks. I can't give you a specific percentage of utilization, but I don't think it's ever come up. Because again, the customer decides what they want to send. And there have been, again, the public sector customers that we have using Wildfire today, if it comes from inside, they don't send it. If it comes from outside, they do.
So that leads into the second question. So if the traffic coming in has that vulnerability or that executable, and it sends it to Wildfire. So I'm envisioning that as the Wildfire catches it, and then the user who's requesting that website also gets it on their computer.
Yep.
So that kind of affects the computer in days of vulnerability on that virus to replicate. Is it already onto my network replicating while you're doing that research?
That's a great question. So basically, in the time elapsed between the administrator being notified, or I'm sorry, the end user getting the malware. So to be specific, it's not an exploit on a particular vulnerability. If it's an exploit on a known vulnerability, we catch it and it would never hit the user's desktop. But let's say it's a new piece of malware, never been seen before. 15 minutes into it, you get a notification that says, hey, Chris's laptop is, poisoned beyond belief. The interesting thing that we found was that spread, and I have a chart, and you can either give me a card or I'll give you a card. The amount of spread that you get is not that fast. So where we saw it, and where we've been able to measure it, I want to say it's in the hours to days time frame. It's in that second day, I think, where it really starts to ramp. But we have specific numbers on this, where it shows how big your exposure is over time. Again, on an anecdotal or case study basis, not on any hardcore large substance, any sort of statistically relevant sample. Sorry, I got distracted. So I can share that with you. And with that, I think we're at time. So thank you all very much for listening to me.